Hello, good evening. I'm continuing with the last part of my presentation on data privacy. See, what happened was I had recorded almost 80, probably almost 90% of my presentation. And then we had an internet outage. It's typical on a Friday night. That sometimes happens. And so I got disconnected and now I've reconnected. So I have only about 3 or 4 charts left. So I'm going to start with the chart where I left off or when I got disconnected, and then I will complete the presentation. And then what I'm going to do is to merge the 2 videos into one video and then upload the video on my YouTube channel. Okay, so I'm now going to share my screen. Okay, so I'm going to repeat this privacy preserving surveillance. Okay, so what I said was I have one student looking at suspicious event detection. So if a person is sort of acting suspiciously, then you want to flag. And I had another student looking at face detection. And so that was another system that a lady, she developed. And so we also, some of the videos were manually inspected. And then we write all these reports of suspicious people. So my goal was the following, right? We wanted to catch the people who were suspicious events and bring the privacy. So essentially, initially, we want to make everyone in public private. So their faces are going to be masked, right? All those blurred faces. And then if they do something suspicious, then our system here. So if they find that this system finds us doing suspicious, then this system will kick in and it will then de-recognize and then de-blur the face and try to use our face detection algorithm to detect the face. And then all the reports are being evaluated. So initially, it's like innocent until you are proven guilty. So everyone is sort of private. We are walking around, our faces are masked, but if we do something suspicious like killing a person or stealing something, then it will de-recognize the face and or de-encrypt or whatever, decode, and then recognize the face. And then the system will know who is this person, right? So, and all these reports are collected, privacy preserving. So that's what I wanted. So I asked a third student to integrate these 2 systems, but then it turned out to be very hard. And also I was talking to some people in Washington, some sponsors, to see whether this was of interest. They said the idea is not very realistic because you can't, encrypt everybody's face, or that means blur everybody's face, right? The surveillance system means you need to see the face as well, right? So we sort of didn't continue with this project, but there were some others who have done also some work on privacy preserving surveillance. Okay. So that's one thing. And I only have like a few more charts. Why does it say remove this window? Just a second. Away from, okay, just a second. Okay, so I think there was a problem earlier. Right, so this is the face recognition, de-recognition. So there was some problem here. So again, everybody is blurred and then masked, and then you do something suspicious, then the face detection system will kick in, de-blur the face, and then detect the face, and then recognize it, and then all the reports are collected, but we abandoned this project. But something useful for us to think about maybe in the future. Okay, so now we talk about, I think about 3 more charts, application-specific privacy. So should privacy be application-specific? Examining privacy may make sense for healthcare and financial, but does privacy work for defense and intelligence applications? To some extent, yes. Is it even meaningful to have privacy for surveillance and geospatial? So once the image of my house is on Google Earth, then how much privacy can I have if people can see what my house is like? I may want my location to be private, but does it make sense if a camera can capture a picture of me and where I am, right? And send that to, and make it public. If there are sensors all over the place, is it meaningful to have privacy preserving surveillance? What I mentioned in my previous chart. So what I'm saying is this suggests that we need application-specific privacy. It may not be meaningful to examine privacy-preserving data mining for every data mining algorithm and for every application. So does it have, can you do privacy-preserving association rule mining, privacy-preserving decision trees, privacy-preserving deep learning, right? So applications. So I'm saying we need to look at the techniques at application-specific. And again, there are several privacy preserving algorithms. How do you evaluate them? So perhaps build a test bed. We need a test bed with realistic parameters, realistic scenarios to test our algorithms. It is time to develop real world scenarios. I believe it's time because there are so many of these algorithms where these algorithms can be utilized. And is it feasible to develop realistic commercial products, or should each organization adapt their products to suit their needs, right? So these are all questions that we need answers, but I think it's time for us to develop a test bed. And there's another direction on the foundations of privacy. So back in 1990, I proved that the inference problem was unsolvable. And then the suggestion was to explore the solvability aspects of the problem. I presented this at the Computer Security Foundation's workshop, and Dr. John Campbell of the National Security Agency, he wrote in the proceedings of the National Computer Security Center Security Conference in 1990 that this was one of the major breakthroughs. I think his words was most significant research, in 1990. So can we do something similar for privacy? Is the general privacy problem solvable? What are the, not a complicity, it's actually complexity. What are the complexity classes? What is the storage and time complexity? I don't know why it didn't show up as complexity. Sorry about that, okay? So what are the complexity classes and what is the storage and time complexity? So we need to, and I did something sort of inference, we reversed it. And so I also wrote a paper on the general privacy problem, and that was back in 2005, I believe. No, not 2000, yeah, 2003, 2000, yeah, around 2005. So we need to explore the foundations of privacy preserving data mining and related privacy solutions, and also develop measures of privacy. So we wrote a paper with Elisa Bertino, Chris Clifton, and Murat Kantaroglu and myself on coming up with metrics, right? How do you measure privacy? And so some of the key points, we know that there is no universal definition for privacy. Each organization must define what it means by privacy and develop appropriate privacy policies. Technology alone is not sufficient for privacy. We need technologies, policy expert, legal expert, and social scientists to work on privacy. Some well-known people have said, forget about privacy. So should we even pursue privacy research, right? Interesting research problems, we need to continue with research. And I feel some privacy is better than no privacy, and try to prevent privacy violations. And maybe if violations do occur, then we've got to talk to the lawyers. We may need to prosecute. And we need to tackle privacy from all directions. There is no one size fitting everything. And my last chart, I believe, this is something Professor Dr. Rakesh Agrawal, he has invited us for a panel on data mining and privacy, friends or foes. That was at the KDD conference in 2003. It was in Washington, DC. So are they friends or are they enemies? My answer, I'm using that same chart, they are neither friends nor foes. You can't say they are friends, you can't say they are enemies. But we need both. We need advances in data mining. Just because for privacy, we cannot not do data mining. And just because of data mining, we cannot not worry about privacy. We need both. And we need systems to be flexible. For some applications, one may have to focus entirely on pure data mining, while for some others, we may need privacy preserving data mining. And for some others, we may just need privacy only. Right? Remember that chart where my students said, Dr. Li Liu, you need 100%, privacy with very little data, no data mining. At the other end, you need just focus on data mining and forget about privacy. We need somewhere in the middle, but again, it depends on the application. We need flexible data mining techniques that can adapt to the changing environments. And in the end, it's not a one-person problem. We need technologists, lawyers, legal specialists, policymakers, makers, by the way. Sorry, I got so many spelling errors. Social scientists, policymakers, and privacy advocates. They must all work together, right, to address these challenges. We need data mining. Now it's gone to data science, machine learning, AI, and we need data privacy, right? So they are conflicting goals in a way, but we really have to bring it together and come up with flexible systems and again, different levels of privacy. And this presentation, right, addresses all of these points. And remember, I have it in two parts because of the internet problem that I had, right? I had an short internet outage. And so this is the data privacy and about almost 80%, 90% of the presentation was covered in the first part. And then the addendum, I had this small piece, right, about 4 or 5 charts. And so I want to try and combine both videos, right? There's a way to combine 2 videos. Hopefully I can do that and then upload the entire video. If I'm unable to combine, of course, I will have 2 videos, but I think I should be able to combine. And again, thank you very much. And stay tuned to the next presentation next Friday. And that is going to be, or maybe even earlier, and that is going to be on my research, my entire research on the inference problem in secure databases. Again, thank you very much. And I'm going to stop sharing the screen. And as I said, we will, my next talk is going to be inference. This one was data privacy. Privacy and inference, right? There are a lot of similarities between the two. We talk about inference with respect to, secure databases, classified data, top secret, unclassified secret, and privacy usually with respect to healthcare, public data, private data, and so on. So there are some similarities to what I'm going to discuss next week, my work on inference, and there are some differences. So I'm saying next Friday, but I might even do it earlier, or it could even be later, but that's going to be my next presentation. And again, thank you very much.